Good afternoon, everyone. Our next speaker is Tom Christie, and he is talking about Level Up, Rethinking the Web API Framework. So please welcome Tom Christie.
Hey. Hello, Portland. Okay, so yeah, my name's Tom Christie. I'm most well known as being the author of Django REST framework, which is an API framework for Django, unsurprisingly. I'm fortunate enough these days to be in the position that I'm actually paid to work on open source. We launched a collaborative funding model about 12 months ago, and I was able to quit the day job. We now have about 50 or 60 different companies who are all signed up as sponsors, and that's what I do day to day in Brighton in the UK. So I'm here today to talk to you about some of the newer work that I've been doing. It's not coupled to Django, it's a new API framework that's been spurred on by some of the thinking that I've been doing around Django REST framework, and how can we take a slightly new approach to building API frameworks in Python. So this is the more verbose title of the talk. How we can build powerfully expressive APIs using function annotations for dependency injection, a type system that can declare our schema constraints and demonstrate what tooling and benefits we get from doing so. In a nutshell, it's all about thinking about how we can build meaning into our code base and write our APIs in such a way that we're making information available to tooling that we can then use to do interesting things with our API. So the way that I'm going to approach this is I want to start with a simple API service that's written in a Django-like style, and I'm going to iteratively propose a set of changes that we can make to how we write this, and then once we've gone through all those changes, demonstrate the benefits that we get from taking this slightly different approach. Okay? So we've got a very simple service which is all about lovely kittens, and it's got two different operations that it exposes to the user. The first operation is the ability to add a new kitten to your favorites list, and the second operation is to show all the kittens in your favorites list, optionally filtering them down to just including kittens of a particular color. So here's what our view function looks like to start with. You don't particularly need to go into the details, but this is our starting point. And the first change that I'm going to propose that we make, very simple one, is to say, well, let's always think about writing our views in a way that we always split out individual HTTP methods. So in a regular function-based view in Django, you would typically have a URL route would point at the view, and any HTTP method on that URL route would get routed to that regardless of what the method is on that HTTP request. So the first change I'm going to suggest is, well, let's always split out the views by different HTTP requests. And the big benefit that we've got from making this simple change, oh look, here's just looking at the routing, how the routing would look differently. In the first case, we'll route everything just based on the URL. In the second case, we'll explicitly filter out the different HTTP methods. And the big benefits that this already gives us is that we have more information if we want to try and write if we want to automatically try and pull out documentation for our API. So in the first case, we've got a single URL route that actually has two underlying operations, different kinds of operations it can do. In the second case, we're able to say, okay, we've got two different doc strings for these two different functions, and we're able to pull each of those out separately and document the different types of operations that our API exposes. So that's a simple change to start with. Let's go with something a bit more substantial next. So the next change that I'm going to propose is, rather than presenting the fundamental abstraction of the view interface being a function that takes a request and returns a response, let's look at the view abstraction as being something that more fundamentally represents what is the interface that we're exposing. So rather than let's have a function that takes this request here and returns a JSON response at the bottom, let's put our actual input parameters of the actual query or the actual operation that the user is intending to do there in the function signature directly. So we've got two different things there. We've got the user, the person making the request, and we've got the name of the kitten that we want to add to our API. At the bottom, at the moment, we're returning a JSON response. Well, why don't we be a bit more fundamental about the interface and return the data that we're interested in? And we'll work at this level, and we'll see why this is going to get interesting as we go along. So if we're going to do that, how do we have the framework know what these different input parameters are, or make those available from the framework to the view? Well, there's actually a really well-established pattern for dealing with this sort of thing called dependency injection, and one really good place in Python land where this is already used is the pytest testing framework. And they use dependency injection in order to write test functions in such a way that the arguments that you provide to the test function automatically get provided by the framework. Now, in pytest, the style that you use for providing those fixtures is you have a decorator and a function that returns the argument itself, and the name of the argument is used to pick out which is the fixture that we want. Now, rather than using this, rather than using the names, a different approach that we could take is to look at using Python 3's type annotations, and use the type annotations to describe what is the argument that we want to pass into this view. So in our request response level that we're starting with, here's how you'd type annotate the view. You've got an HTTP request coming in and we're returning an HTTP response. As we start to look at moving away from request response and moving to this more fundamental level of the interface, we can have particular type annotations that correspond to, say, just the user that is associated with the incoming request, or a query parameter that is present in the incoming HTTP request. And we can do a similar thing for the return type as well, and say, rather than returning an HTTP response, I'd like to return some response data, so an arbitrary data structure that is JSON serializable, say. Now, if we're going to do this, we need to have a way of describing to the framework how should the individual components be created in order to pass them to the view. Here's an example of how we can do that, is registering builder functions that are the thing that say, if you've got a parameter of this type, here's how it gets created. Okay, so don't worry too much if it doesn't all fit together. As things progress, hopefully you'll just kind of get a good idea of what the big picture is. Right? So we can then, once we have these components that are able to, that the framework is able to know how to build each individual component, we can just drop them, each individual one that we need, onto the view. What starts to get interesting here then is we have this very dynamic style where we're actually able to work at lots of different levels of abstraction depending on what we actually need. And request response no longer becomes actually the primary abstraction, but in fact you could work at lots of different levels of abstraction. If you need, you could write a view which drops all the way down to the raw WSGI layer, WSGI being the interface layer that exists between the server pulling the request off the network and the application code. And the framework is able to dynamically build up exactly what it needs to run in order to satisfy the interface of the view. Where are we at the moment? Okay, right, so let's now add in our components into our Kitten API and see what they look like so far. And we're starting to have an interface that more meaningfully exposes what these operations actually are. And one of the benefits of this is that it makes for more testable interfaces. So for example, if you want to test one of the operations directly, you don't have to mock up an HTTP request, pass that to your view function, and then get back a response and decode the data in that and see if it's right. Instead, you can just test the interface directly. So this is an example of writing a test against the request response interface. You can see we build up a request and pass it to the function. Instead, we can just test the interface directly. Okay, the next thing that I want to move on from here is to talk about how we can put more semantic information onto the input and output types in order to describe the data structures that our API expects both as input and as output of the API. And as a starting point, I'm going to take a look at JSON Schema. Now, JSON Schema is a very widely used representation for expressing the data structure and the constraints of a structure, of a JSON data structure. Okay? And it's one of the things that's nice about it is it's a format that allows you to express those constraints in a way that you can then use it with lots of different sorts of tooling. It's something you can pass over the wire, so you can run the same validation on the client side as you run on the server side. And it can be used for documentation of documenting what the interfaces expect. It allows you to express all the basic primitives, container types, which types should be present within one of the container types, so an array of integers, an object which has various different properties on it, and more complicated things as well, such as unions, saying the data structure should either be this style or that style, or an array of either kittens or birds, which each have different properties on them, say. Here's a quick look at some of the sorts of things that you can do with JSON Schema. First example, something that should look like a valid email address. Another example, a number between these two bounds at this degree of precision. and also composite types, building up more complex data structures and expressing what those look like. More of the same. So how can we do something interesting and useful with this? Well, one nice way to do this would be to create a type system for Python, a type system that we'll be able to use in our type annotations that expressly maps onto JSON schema. Okay? So we will have primitives that correspond with the JSON schema primitives and attributes on each of those that correspond to the various constraints that you can put on each of the different data types. And once we have these basic data types, we'd be able to instantiate them. They'll act as a regular Python primitive object, but we'll know that once we've got an instance of this thing, that it's been validated for us. We know that we've got data that fits the validation constraints of. And what else have we got? Yeah, there you go. So the types will enforce our validation, and we can build up more complex schemas as well. So schemas that represent objects with various different properties, or unions, or any of those sorts of things. And more complex types will enforce validation on their subtypes as well. So once we have a type system, a rich type system that expresses constraints on the style of the data, we can use that within we can use those as type annotations. And once we're using those as type annotations, we have really semantically rich set of information about what the inputs and the outputs of these functions look like, which starts to give us some really, which gives us a lot of leverage onto building tooling that can do interesting things with our APIs. So, for example, we can more easily generate API schemas based on our views. So, for example, Swagger, which is a document format for representing APIs, we have a very clear mapping between saying how do we build up a Swagger document for our API based on our type annotations. Or we can do nice things like build HTML forms that correspond to the inputs on our functions and that have appropriate kinds of controls on them. So, for example, if there's an enum on there that has a set of various different options presenting a drop-down for those, or if there's an email on one of the form parameters having an email form control. So, here's our API as it is at the moment. Now let's take away the query parameter and the request data, the response data, and instead add our more richly expressed types onto there. Now at this point, the framework is going to be responsible for figuring out which of these different components map onto which different aspects of the incoming request. So for example, the framework needs to be responsible for figuring out that the kitten color should be a query parameter on there. And what can we do with this? Why is any of this worthwhile doing? Answer, right. So if we build our APIs in this sort of way, one of the first things that we can do that's really beneficial is once we have declared our views and our schemas, even before we've implemented anything else at all, we would be able to run a mock API based on that information. So we could start running this mock API and say to our front-end team, hey, we know what the style of this thing is going to look like. We know what the data structures all look like. You folks can get working against this. We're going to be filling in the blanks of the implementation details as we go. And from day one, your front-end team has something to start working against. Also promotes thinking about how you approach the design in a very API-first way. You're not thinking straight away, okay, what do the database representations look like? Which database are we going to use? Any of the implementation details at all. You start thinking about the interface first, up front and center. Another thing that you can start to do with this is one of the things that, well, really the big driver for Django REST framework was the web-browsable APIs that it introduced. And in the way that we've built these views, we now have really rich semantical information for being able to build up interactive modals for interacting with your API directly in the browser and be able to bring up the right set of controls for each endpoint. We can also use all of this information in order to build interactive API documentation. We've got all this information both in the doc strings and in the type annotations to give us everything that we need to be able to automatically generate documentation for the API as a whole and cast iron guarantee that our documentation is always in sync with our code base. Okay? Another really interesting thing that we can do is provide dynamic client libraries. So a client library that uses the schemas that we can generate from this information in order to drive presenting to the user, here's the interface that's available to you. And as a result of the work on Django REST framework, we've already got client libraries for JavaScript and Python and a command line client that are written in this way of you point the client library at the schema, and it's then able to express that interface to the user in either JavaScript or Python. So here's a quick look at how that would look. This is using the command line client. You can see what we do to start with is we point it at the schema for the API, and then we add some authentication information. And once we've done that, the interactions that are available from our API are available on that client. Another nice property is, as well as being able to route HTTP commands onto our views, we can route different kinds of interfaces onto them, as well as HTTP. The most obvious one of those would be routing command line commands directly onto the same function that we're using to return HTTP responses. So this little example shows how we would route both HTTP and CLI commands onto the same view, and what that would look like on the console. You also start to have the possibility of doing even more interesting things, such as routing a WebSocket route onto the exact same view that you're using for your HTTP. Because you're not at the request response level, instead you're at here's our inputs and here's our outputs, we can, as things progress, point these different types of protocol at the same view. And the framework would then be responsible for handling the nitty-gritty details of, okay, for an HTTP request, fine, run the view, return the data, no problem. For an incoming WebSocket request, run the view, return that data to the client, and every time that the data is changed, rerun the view, get the diff between the last set of stuff that we returned to the client and the new set of data, return that diff to the client. Okay. So that would be quite an exciting thing to be able to do. So, type annotations for dependency injection onto our view interfaces, and a type system that gives us a rich way of expressing the validation constraints on the inputs and the data structure of the outputs, gives us all of these good things. Now, this is something that I've started working on. I have an API framework that's about 2 months old at the moment, API Star. I've been working hard on this, and I'm going to show you where we are at the moment with this, just to give you a bit of a feel. So this is my, I don't want to do live coding anymore, because I'm too chill. So we've installed API Star. There's a little command that will give you a new project. And let's run that. So this is the API documentation that it'll give you out of the box. And you can see that we have controls for interacting with the API. We also have controls for choosing different authentication methods. So at the moment, it's got support in the documentation client for basic authentication, or for, what's it called? We'll just say token authentication. And also along the side, what you can see there is the different client libraries are also documented using snippets to document them. And we've got the Python, the JavaScript, and the command line client at the moment. So that's that. That's where we are at the moment. The functionality of being able to run mock APIs, there's not much work that's needed there. That's probably the next big bit of functionality that I'll be putting in place. We haven't yet got web-browsable APIs, so although we have the API documentation itself, we don't yet have the go directly to the endpoint, the API endpoint that you specifically want to interact with, and have a web-browsable way of interacting with that directly. And I don't have any of this funky real-time stuff that I've been talking about just yet. So the way that the framework operates, when you register one of the views as having a URL route that points towards it, or a management command that points at it, is the framework is able, at the point that it's initialized, to build up the chain of all the different functions that it needs to run in order to satisfy the interface of that view function. And one of the interesting things about that is that means that if you want the framework to get out of your way, then it can. You can drop all the way down to the simplest possible level of don't give me any higher level abstractions, and just return a WSGI response directly. Now, this is kind of silly, because this isn't actually a very typical use case, but nonetheless, it's a nice point of reference that you're using a framework that you know that if it needs to get out of your way, it will. So Tech Empower are a company who run benchmarking for lots of different application frameworks, and we recently added, they have about 6 different test types that they use that get progressively more realistic, and their little JSON hello world one is one of the least realistic, but is also one of the simplest ones. We've added support for that so far, and out of all of the JavaScript, Go, Ruby, and Python frameworks that are out there, API Star is faster than anything else. Like I say, there's big provisos onto that, and as soon as you start doing other types of things, in particular things with blocking operations, you'd see different results. But I think it's a nice starting point nonetheless. I'm going to go and talk a little bit about some of the other types of component that you would put onto these view functions. Consider some of this just as sketching out stuff at the moment. So the style in which you're expected to write your view functions in API Star is all about geared towards explicit dependencies onto the view. So for example, if you want to be able to use the database in a view, rather than having this style that, say, Django has, where you just access one of the models and magically a database transaction has somehow been wrapped around all of that. Instead, you should always be passing the database session to the view explicitly, and the framework will take care of this for you. But what it does mean is that because you're declaring, I'm going to use the database here, in those cases, the framework can make sure that that view is wrapped up in a database transaction. And in cases where you have a view that doesn't hit the database at all, it won't bother doing that. It doesn't need to. Other sorts of things that you would want to inject explicitly, rather than just importing requests and calling the requests library directly, I think that it makes more sense to have this style where you put explicitly on the view, hey, I'm going to use requests. And then the nice property that that gives you is when you are, when you're testing your API, you can make sure to say, okay, we're not actually going to pass the real requests library to this view. We're going to make sure that you actually mock out what responses you're expecting so that your tests aren't actually hitting the network. Also, more just as interesting to think about rather than this is what we're doing right now, things like date and time, okay? Typically what you'd do in a Python function is just call date time directly, but that's a pain when you're writing tests because you don't know what date or time you're going to get back. Now, putting those as explicitly declared components on the view is nice because then when you're in test mode, you can pass those in directly. And this is just a little bit of flavor for how and why you might want to do that. So the framework would take care of, by default, providing date time to your now case, and similarly for randomization stuff. Anyway, stuff. Let's go. Okay. So ASCII. ASCII is something that has come along in the Django world, specifically in order to support a deployment mode where Django can be used with things like WebSockets, and not just be, the deployment mode previously has always been WSGI and has always been geared towards it's a framework that takes requests and returns responses. Well, what do you do with other types of network events? Now, just a bit of flavor about how we would add support for ASCII alongside the existing WSGI support. Our component builder functions, we'd be able to register multiple types of component builders that each have different dependencies themselves. And the framework will be able to take care of figuring out, when I'm in this mode, these are the sets of things that are available. I wasn't able to route the query from WSGI onto this view. Oh, but wait a minute, I was able to route the query from ASCII onto this view. I know that that's probably a bit fuzzy at the moment, but just as flavor. Something that I brushed over a bit that I'll go into a little bit more detail about is how you could support both real-time interfaces and standard HTTP calls from the same view. Well, one of the things that I brushed over was how do you inform the event of, hey WebSocket, your view onto this data has changed. So you would have components that give you that event interface. And you'd have the kind of the two sides of the coin, the listener and the thing that pings it. And if it's an HTTP request that's coming in, your subscriptions.subscribe would just be a no-op, but your subscriptions.update in either case would always be, let's send a WSGI message that's going to make sure that we update anything listening for real-time events on this view. Another thing that I'm planning to move into in the future is views that support both GraphQL interfaces and HTTP interfaces. So one of the considerations for if you want to be able to do this is what should relationships between two different data types look like? And in particular, what should they look like when you're just in regular RESTful HTTP API land in order to have a nice, seamless way of also being able to map that into GraphQL. Now, in REST framework, we have a rich set of different ways of representing relationships, and all of these are valid different ways to talk about, I've got one object and it's related to this other thing over here. The bit of the sensible thing to do if you want to be able to express these relationships in a way that either works well for GraphQL or for standard REST queries is to always, however simple your relationship is, even if it's just a primary key, always nest that inside an object, inside a top-level object. And that way, you can always extend it out to including other information as well if you need to. And what this will end up meaning in API Start is that we'll end up having something like a query component, and when the query component is being routed to by an HTTP view, we'll automatically provide a default layout for the representation, and when it's being routed to by GraphQL, we'll provide the full GraphQL query that's hit that endpoint. Anyway, I know this has been a little bit fuzzy in places, but I'm really excited by API Start. It's coming along really, really quickly. Python, I think, is in a really exciting position at the moment. I haven't talked about asynchronicity in terms of the new async primitives that are in Python, but the fact that libuv has shown that Python can be competitive against Node and Go on their terms, and the fact that Python is such a hugely expressive and productive language means that I think we are in the position that the next set of API frameworks that come out of Python land could be really, really compelling. And anyway, I'm going to be sprinting on this on Monday and Tuesday. I would love to talk to you, any of you, about anything that I've mentioned here. And I guess that's about me. Thank you very much for listening. Hey, how you doing?
Question?